we will learn about another kind of register, which is shift register. From its name, you can understand that it works the operation of shifting, means it will shift this from one to another. So this register will shift in binary information. This is another kind of register where it is possible to shift the binary data between the neighboring flip-flops of the register. Means there will be flip-flops. Suppose here will be 4-bit flip-flops and they are interconnected because they shift one binary information to the another flip-flop. So suppose here is the binary information input give into our first flip-flop, then it will shift this information into second flip-flop. The second flip-flop shift the information into third flip-flop, and the third flip-flop will shift the information into fourth flip-flop, and we will got our output. This is how the shift register works. Let's see the definition of shift register. A register capable of shifting its binary information either to the right or to the left is called shift registers. Means its main work is it shifts binary bit of information. But this shift register is of two types, left shift and right shift. What is the application of this shift register? It is used to implement the arithmetic operations. Arithmetic operations means plus, minus, multiplication or division. For addition or subtraction, we have already two circuits, which is adder and subtractor. But sometimes it may seem complex. How it may seem complex? Suppose we have to add 2 plus 2 plus 2 equals 6. Here we have used 3 adder. But if we multiply this into 3, then we'll got 6. So the use of adder, here we have to use multiple adders, but here we don't have to use multiple devices. So it may seem complex sometimes and it is more easier. So the work of this multiplication and division is done by the shift register very easily. Let's see how it does. First of all, let's understand what is left shift and right shift. Suppose we have a binary information of 0, 0, 0, 1. Left shift means it will shift this one bit 1 from this to this, means the next shifting, after shifting the binary information will be 0, 0, 1, 0. Means this 1 is shifted here, this 0 is shifted here, this 0 is here, and this 0 is here. Then again after third shifting we will get this, means this 1 is shifted here, this 0 is shifted here, this 0 here, and this 0 will be here. And our third is 1, 0, 0, 0. This 1 is shifted here, this 0 is here, this 0 is here, and the last 0 is here. This is how it shifted the left shift registers. And see how it does the multiplication and division work. This binary information represent 1 in decimal number, this represent 2, this represent 4, and this represent 8. So if we multiply 1 into 2, we will get this. And if we multiply this 2 into 2, we will get this. And if we multiply 4 into 2, then we will get the 8. So the left shift work as the multiplication. And let's see the right shift. Suppose we have information of 1, 0, 0, 0. As it is right shift, means it will shift the binary bits from left to right. Means this 1 will be shifted there. So 1 will be here, this 0 will be here, this 0 will be here, and this 0 shifted here. And for the third clock pulse, this 0 will be shifted here, this 1 will shift here, this 0 and this 0. And for fourth clock pulse, after shifting, we will get this as 0, 0, 1 and this 0. Here this represent 8, this represent 4 in decimal number, this 2 and this 1. So if we divided this by 2, then we will get this 4. Then if we divided 4 by 2, then we will get 2. And 2 by 2, then we will get 1. Means it works the function of division. This is how it makes easier our arithmetic operations. This is one of the application of shift register. Let's see. This shift register can be loaded into two ways. Means the input and output of this shift register are designed in two ways. They are in serial input or serial output, and another is parallel input and parallel output. And with these two input and output combination, we will get total 4 combination. One is serial input, serial output. Serial input but parallel output. Here parallel input, serial output, and parallel input, parallel output. Let's see how these four combination works as shift register. Let's see the circuit diagram of shift serial input and serial output. This is the circuit diagram. Here the we have drawn 4-bit register which are connected internally, and here is one serial input and one serial output. As they are connected sequentially and only one single input, only one single output, that's why it is called the serial input, serial output. And here only one single clock pulse is applied to the fourth flip-flops at the same time. The logical configuration of shift register consists of a chain of flip-flops. This is a chain of flip-flops connected in cascade. Cascade means one after another. This flip-flop after this first flip-flop, then after this second flip-flop, this third flip-flop is connected. Through this, all the flip-flops are connected with each other. This arrangement is called the cascade form. With the output of one flip-flops means we get here one output, and this output will be connected to the input of the next flip-flop. For the first flip-flop, this is the next flip-flop. We get the output from the first flip-flop, and this same output will get as input for the next flip-flop. And then again for the second flip-flop's output, it will get into the input as for the third flip-flop. This is how all the flip-flops are connected. All the flip-flops receives one common clock pulse, means one common clock pulse applied to the all flip-flops, which causes the shift from one stage to the next. Means it will shift our binary information from this flip-flop to this, then this flip-flop to this, and then third flip-flops to fourth flip-flop. Let's see an example how it shifts the binary bit information. Suppose we give the input as our input binary information is this. As we have used 4-bit flip-flop register, so here we have used 4-bit binary information. But as here we have only one single serial input and only one single serial output, then it means that we at a time we can give the input as only 1 bit. So from this we at first give only this 1 bit as our first input. So if we give the input as 1, then we will get the output as 1. So let's see the table. If at the first all the flip-flops are in the reset condition, means the output of all the flip-flops are 0 0 0 0. After we give the first input as 1, we get the output of first flip-flop as 1, and there are no output, so they remain unchanged. Means this first will be 1 and all the output of these 3 flip-flops will be 0. Then if we give this second input, then at first it gives like this, and when we give the second input, then this passes through first flip-flops and this previous one passes to this D input of the second flip-flops, and we get the output of this as 1. So here we got this one from the first flip-flop and this one from the second flip-flops, and the output of these 2 flip-flop will be 0 0. Let's see, it is the first clock pulse 1, it is the clock pulse 2. Let's see what happened at the clock pulse 3. If we give the third clock pulse, then our third binary bit will be get in through this. So this one will be transferred or shifted as the output of first flip-flop. So we will got the output of the first flip-flop as 1. Then this in 1 will be shifted through this second flip-flops and will get the input of second flip-flop as 1, and our very first output 1 at the second flip-flop, it already transferred to this, and from here it will be shifted through this, means a third flip-flop. So the output of the third flip-flop will also be 1, and here will be no output, so it remains unchanged, means 0. So at the time of fourth clock pulse, this 1 output will be shifted through our last flip-flop and we will got our output as 1. So the output of the fourth flip-flop will be 1. Then this one will be transferred through this. So the third flip-flop's output will be 1, and this one shifted through this. So the output of the second flip-flops will be also 1, and our very first bit is given as input for the first flip-flop, and this will also be 1. So we'll get our required input after flow 4 clock pulse. This means that here will be the number of clock pulse. Number of clock pulse is equals to the number of bits. Means if we give here input as n bit binary information, then we will need n times clock pulse to get our required output here. But as here is the only one line for our output, so we will got this only one as our output, and we can see the output. And if we give the 5th clock pulse, then this output of the 3rd flip-flop will be go through this, and it is shown. So for this shown for the clock pulse 6, this one will be shown, and for clock pulse 7, this total 4 output will be shown. So here needed 7 clock pulse to show all the 4 outputs, and for transfer our input in binary information, we will need a number of flip-flops and clock pulse. This is how serial input and serial output shift register works. So now let's see how this serial input and parallel output shift register works. Let's draw the block diagram of this. Suppose we have 3-bit register, and as it is serial input, so here the only one single serial input, this is serial input, and as it is parallel output, so we will got the parallel output Q1, Q2 and Q3. So if we give the binary input as 101, but as it is in the serial input, so we will give the input as first 1, then 0, then 1. At a time we will give only 1 bit, but we will get the output at a time because we have 3 output lines. But at the time of serial input and serial output, we got the one single output at a time, so we will need this extra 3 clock pulse. But here we at a time we will get all 3 outputs, so we will don't need no extra clock pulse. And now let's see the parallel input and serial output. Means here the input is parallelly and the output will be serial output, means one line. Suppose here is also 3-bit registers, and this is our serial input, and we will got only one single output, which is Q, and this is I1, I2, I3. Means this binary information will give the input at a time, but we will get only one single output at a time, means 1 clock pulse. After 1 clock pulse we can give all the inputs, but after the first clock pulse we'll get only one single output, so here we need extra clock pulse to get all the outputs. Now let's see the parallel input and parallel output. Here the input and output both are in parallel, so here the input are in parallel and output are also in parallel. This is denoted as I1, I2 and I3. Output will be Q1, Q2, Q3. For the both register, only one single clock pulse is applied at a time to the all flip-flops. So if we give here this 101 as input, then as it is in the serial input, so we can give this 3-bit binary information at a time, and we will get the output all the binary information at a time. Means here we also don't need any extra clock pulse. All the 3-bit will be shown at a time because we have parallelly output, means we have 3 lines of outputs at a time, but only 1 clock pulse will be applied for the all cases. I hope you will understand the register and shift register with parallel load. If you have any questions, then please ask me in the comment section.